basic properties of magnet. Okay, so the first property of a magnet is attractive. When I say attractive, it means that a magnet always attracts a small pieces of, let's say, of iron, nickel, or cobalt, and etc. And the ends where the magnetic, attraction is maximum are called the magnetic poles. That means, like, suppose I'm taking a bar magnet here. Now, at these two ends, okay, the magnetic attractions is very, very strong as compared to the, to the other end. Like, if you put a nail here, right, and here, and here, you will find that this nail, it is strongly attracted at this point, and less attraction at this point. Okay, this is less attraction, but at this point, right, the attractions of the nail is very strong. So that is why we call these ends of the magnet, which has got a strong attraction, as the poles of the magnet, and so we name them as North Pole and South Pole. Okay. Okay, the second property of a magnet is directive property. A freely suspended magnet, like this is my bar magnet. If I suspend it freely, okay, on the surface of the earth, right, if you suspend it freely, then what will happen? This magnet will always point in the north-south direction of the earth. Okay, because we know, right, in the earth we have what? We have a geographical north and south. So when this magnet it is suspended freely, then this magnet will point in the north-south directions of the earth. And this pole of the magnet, which points towards the geographical south of the earth, is known as a north pole. And this pole of the magnet, which points towards the geographical south of the earth, is known as a south pole. Okay. The third property is like poles repel and unlike pole attract. Okay, so just like in electrostatic we have like charges, they repel each other, and unlike charges attract each other. So similarly, if I have two magnets, one is south pole, here is north pole, and if I take another magnet and I face the north poles, right, each other or close to each other, then these two magnets will repel. But if this is a south pole and this is a north pole, then when you place the magnet in this way, you will find that these two magnets attract each other. Okay. Okay. And the fourth property is magnetic poles always exist in pair. Which means, if I have this magnet, then this magnet should always contain south pole and north pole. You cannot have both as north pole or only just one pole, which means only south pole, but the other end has no pole at all. So that is not possible, because according to the property of a magnet, poles always exist in pair, which means if one is south, another should be north. The fifth property is magnetic induction. When I say magnetic induction, it means, like, okay, if you have a magnetic material or a magnetic substance, okay, suppose I'm taking a steel, for example. If you place this steel near this magnet, then this magnet, it will induce, okay, a magnetic field, or it will induce a magnetism in this substance. And now this substance, right, it becomes a magnet. Okay, so this property, it is known as magnetic induction. Okay. Okay, here we will talk about some important definitions connected with magnetism. So we will see about the first definition, like magnetic field. So what is a magnetic field? Okay, suppose this is my magnet, in which this is a north pole, this is a south pole. And if I draw a region around this magnet, then I get this space here. So this space here is known as magnetic field. Why I call magnetic field? Because, right, any object, any magnetic material, right, when it comes inside this space, it is always, it experience the the influence of the magnetic of this magnet. But if any magnetic material it is outside this region, then it will not experience, the influence of the uh, magnet. So that is why this space here which surrounds the magnet is known as a magnetic field. Alright? Okay. And the second definition is uniform magnetic field. So when I say uniform magnetic field, it means, the magnitude is the same. Okay, magnitude and direction of the magnetic field is same. Okay, now I will show you three different uniform magnetic field. If the magnetic field, right, are acting along the plane, okay, then such uniform magnetic field, okay, can be represented by parallel lines like this, and these lines, they are equally spaced. Okay, so this is about the first representation of a uniform magnetic field which is acting in the plane of a paper. Okay, now the second uniform magnetic field, right, let's say if the magnetic field is uniform, but its direction, it is acting perpendicular to the plane but in the outward direction. So that means I have a magnetic field acting outward like this. Then the representation for such magnetic field, right, it is given by the dots. So these dots here stands for a uniform magnetic field in which its direction, it is perpendicular to the plane but directed outward. Okay. Now, another representations of magnetic field is a uniform magnetic field in which the direction is directed normally to the plane of the boat. So when a uniform magnetic fields are acting perpendicular to the plane of the boat, then such uniform magnetic field can be represented by a cross. Okay, so these are the three types of uh, uniform magnetic field with a different direction. Okay, so when the field is acting along the plane, this is the representation. When the field is acting perpendicular to the plane but outward, this is the representation. And when the field is acting perpendicular to the plane and directed inward, so we represent them by a cross. Okay, now the third definition is magnetic poles. So what is a magnetic poles? We have seen, right, there are two types of poles. One is north pole and the other is south pole. So these magnetic poles, they are these are the regions of a magnet in which the attraction is maximum. Okay, I think I have explained this before. If this is my magnet, right, so at this region, if the attractions of the object at these two regions is very, very strong, so these regions here stands for the poles of the magnet, right, which means this may be a north pole and this will be a south pole. or this is north, this is south. Okay, so that is a magnetic pole. And the fourth definition is magnetic axis. So what is a magnetic axis? Alright, this magnetic axis, if you have a line, I mean a magnet, consider in this way. So any line which is passing right along the axis of the magnet. Okay, so this line is known as magnetic axis. Okay, or I can say a line which is passing through the poles of the magnet, because this is south, this is north. So if you have any line passing through these poles, then this line is known as magnetic axis. Okay, definition number 5 is magnetic equator. Magnetic equator, it is a line drawn perpendicular, okay, to the center of the magnet. So this line here, this perpendicular line passing through the center, is known as magnetic equator. And the sixth definition is magnetic length. So what is magnetic length? The distance between the south pole and the north pole, the distance from here to here, is known as magnetic length. And right, we shall denote this magnetic length by 2L. Or in some book you will find this is written as 2R. Okay, because this is the center of the dipole, I mean center of the magnet. So if from south to north is 2L, that means from south to O it is just L, and from O to N also will be L. Okay, alright, so I'll stop here for today. We will continue again in the next video.